Geometry class. This is section 7.4 for similar triangles. It is 2:10 in the morning. I've got a very sick kid at home, so I'm recording this lesson for you now while I can't sleep anyway. So side, 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 and side angle side, those were two of the ways that we were able to prove that triangles were congruent to each other. And we talked about that kind of the other day, but it's also a way of proving that triangles are similar to each other, but it's just side, side, side doesn't necessarily mean exactly the same thing. For congruence, side, side, side meant we're proving that each of the sides in one triangle was congruent to each of the sides in another. But for side, side, side similarity, we're proving that the relationship or the proportion of the sides, one over top of the other one, has the same scale factor for each of the three sides. And if we're able to prove that that's true, then the two triangles are similar to each other. So going down here in example 1, we've got part A. They want us to relate each one of these sides and see if they have the same scale factor. So I'm looking here. I know like side 6 is going to correspond. Side 6 is going to correspond to 15. Okay, so I'm going to put 6 over 15. 6 over 15. And then side 8 corresponds to side 20. So 8 over 20. And then I have 12.5, or no, excuse me, 5 over 12.5. Okay. And then what you could do is you could look at like half of this individually. So look at the first two, and then you could cross multiply and divide and see if that came out the same, and then look at the second two. Or you could just take in your calculator and take 6 divided by 15, 8 divided by 20, and 5 divided by 12.5. If you do that in your calculator, you get 0.4 and 0.4 and 0.4. So each one of them is going to be 0.4. So you know that all those sides have the same scale factor, have the same relationship. And by side, 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 they are similar triangles. So they want us to write a similarity statement. So we would say that triangle, let's call it PQR, is similar. Ooh, that's supposed to be a little squiggly. Similar to triangle. P goes with S, so we'll start with S. Q goes with T, so STR is how you want to write that. Okay. Part B, they have 4.4 is one of my sides. 3.6 is the side that's going to correspond to that because it's kind of like the longest side of each triangle. So I'm gonna relate that with 3.6. Let's see, 2.4 is going to correspond to 1.8 on the other side. And then 3.5 is going to correspond to 2.7. Okay, if I do this in my calculator, let's see if I can remember these numbers. I think this is like 1.2 repeating. This one is 1.3 repeating. And then this is like 1.29 or something like that. Okay, you can check those in your calculator if you want to. If you divide each one of those, you do get a different number. So this one is not similar. No, not similar triangles. Okay, so you're just looking at the scale factors. So by side, 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 this one is similar because all the sides have the same proportion. This one is not similar because the sides have different proportion. Okay, in example 2, I've kind of already got this one set up for you, but I'm going to go ahead and plot these points over here first. They have triangle ABC, and we're trying to compare that with XYZ and see if those guys are similar to each other. So A is at the point -2, 1. B is at 3, -1. And C is at 1, 4. So ABC is this triangle here. Let's see if I can draw it very well. Okay. Yeah. Do a little bit better of a job than I did. ABC. There we go. Okay. And then XYZ is -2, 4. That's X. y is 2, -6. Y and z is -8. -2, something like that. Z. Okay, so he looks something like this. They look like they might be about the, wow. We're just going to erase that. They look like they might be about the same shape. Obviously not the same size, but might be the same shape. So these ones are going to be slightly unpleasant when you do these on your homework assignment. You'll have to do the distance formula 6 times, which writing it out with this pen took me forever, but it shouldn't take you too long after you do it so many times. You kind of just can do it in your sleep. So for side AB, I got a square root of 29. Side BC, I got the square root of 29, and then AC, I got a square root of 18. XY was square root of 116, YZ was square root of 116, and XZ is the square root of 72. And then what I did was I took each side and related it to the one that corresponds to it. So this 29, the square root of 29 corresponded to the square root of 116. This 29 corresponded to this square root of 116, and this square root of 18 went with 72, square root of 72. So I put those over top of each other, and I divided them in my calculator, and on each one I got 0.5. You can check that if you want to, but if you plug those in, square root of 29 divided by square root of 116, and so on and so forth, you'll get 0.5 every time. So by side, these are similar triangles. Yes. There we go. Okay. If you need to pause the video and you want to write all this distance formula stuff down, you sure can. But side tells me, yes, those two are similar triangles. Okay. All right, next page. This is side angle side. So in congruent triangles, we would prove that this side here and this side here are the same. This angle and this angle are the same, and this side and this side are the same. So kind of the same thing for similar triangles, except instead of proving that the side lengths are exactly the same, we're proving that the proportions are the same. Okay. Now the angles will still be the same measure. So S and Y will still be the same measure, but the sides will be proportionate instead of congruent. So down here they're having us test this side angle side. So we have this side, and the angle, this is the most important part, the angle has to be the one in between the two sides that they give you. So T and W, they don't tell us in part A that T and W are exactly the same. So I could have T being, I don't know, maybe 40 degrees and W being 20 degrees. And those sides could be 4 and 4, and these sides could be 2.5 and 2.5. But those aren't going to be similar triangles. Okay, it has to label and tell me that both of those angles have the same measure. So these are not similar by side angle side. Okay, now this one over here, I went ahead and split the two triangles out. So the smaller one and then the larger one. The smaller one has sides that are 8 and 10, and then this one has a side that's 12 if you add 8 and 4 together, and 10 and 5 make 15. Okay, now I already know that this angle and this one are the same because they're like lying on top of each other. They share that same angle A. That's like that reflexive property that we've talked about before. Okay, those are lying on top of each other, so I know that those are the same angle. Okay, so I just need to test and see if these are proportionate to each other. So I can do like 8 over 12 has to be equal to 10 over 15, and let's see, if I divide this one by 4, that would be 2/3, and if I divide this one by 5, that would be 2/3 also. In your calculator, it will come out as 0.6 repeating for each one probably. So yes, by side angle side, these two are similar because I have said this side has the same proportion as this side, and the angle in between them are the same. So side angle side tells me yes, those are similar triangles. Okay, example 4. I went ahead and set this one up already for you as well, but I'll go ahead and graph They have triangle ABC, and then they have triangle DEC. Now, this was kind of confusing when I went through it the first time, because DEC, they only give you D and E, but they're saying that ABC, the C from ABC, is the same C as DEC, so you'll use that coordinate for both triangles, okay? So ABC is -2, 7. There's A. B is -2, -8. There. And 4, 4. There's ABC. Can you hear my child sleeping in the background? She's sitting on my lap right now. All right, so this was C, and this is the side that they're going to share. Okay, now we want DEC. So D is 0, 6 right here, and E is 0, -4 right there. So really, whoa, that should be a straight line. This is my triangle DEC. Okay, so this triangle is living on top of that other one. Okay, they are sharing angle C, so I already have that checked off. The angle in between them for the side angle side checks off. Okay, and then I just do the distance formula. I just do the distance formula from A to C, and I do from B to C. And those I got as the square root of 45 and the square root of 180. And then I do from D to C and E to C, which I got the square root of 20 and the square root of 80. And then I put the square root of 45 over the square root of 20. Now, that's important. Don't try to put the square root of 45 over 180. Well, I guess you could too. It would work out that way too. But the square root of 45 I put over 120, and the square root of 180 I put over 80. And on each one of those, if you divide it out, you get 1.5. So by side angle side, those sides are proportionate. The angles are the same. So yes, they are congruent. Or not congruent. They are similar. Okay. Example 5 is the last one. They're doing the shadow thing to you again. And this one is labeled as 5.75 feet and 5.2 feet. So you don't have to convert inches to feet. You're already good to go. So I separated these out. Here's the person standing, and here's where the tree is. So this one is 5.75. And this bottom side is 12. And we're trying to find H. And this bottom side is both of those two added together. So 17.2. Okay. So I set this up as a proportion. You can do this proportion any way that you want to. So you could do 5.75 over 12 equals H over 17.2. You can do 5.75 over H equals 12 over 17.2. There's many different ways that you can set this up, and they are all correct. So I'm going to do, let's do 5.75 over H equals 12 over 17.2. And this one I did not calculate out ahead of time. If I cross multiply 5.75 times 17.2, let's see if I can do this in the dark. 5.75 times 17.2 is 98.9. 98.9. And that's going to be equal to 12H. And then I just divide by 12, just like we've always done. And H is divided by 12. 8.24. That's not a very tall tree. Must be a little baby. 8.24 feet approximately. Now, this does not necessarily mean that it's 8 or that's 8 foot and 2 inches. Okay, 8.24 feet is going to be almost 8 foot 3 inches, because that's almost a quarter of a foot. So almost 8 foot 3 inches is what that is. I still had some of you guys on the quiz yesterday put, I think it was like 4.9 feet or something like that, or 4 foot 9 inches, you put as 4.9 feet. Don't do that. Okay, it's not necessarily 8 foot 2 inches. So it's 8.24 feet. Let's just leave it like that. But think when you actually convert it, it will be 8 foot about 3 inches. So there is that. That's example 5. That's section 7.4. And I hopefully will see you tomorrow.